Welcome to the deep dive. We have quite a stack of updates for you today, all coming from a mid-December 2025 edition of the Google Cloud Platform Technology Nuggets newsletter. And looking through it, there's a clear story here. It really feels like AI on Google Cloud is, well, it's finally growing up.
That's a perfect way to put it, actually.
So our mission today is to kind of trace that story. We want to cut through all the noise and see how these tools are going from just clever novelties to being the fundamental backbone of cloud infrastructure. We'll see AI learning to talk, learning to use tools, and even, well, learning to work in a team.
Yes, for so long, AI was this separate thing in a box that you'd call out to. What these updates show is a very deliberate strategy to weave AI into the very fabric of everything you do on GCP. This isn't just about new features, na? It's a shift in philosophy, and it has big implications, whether you're building your first app on Cloud Run or, say, managing a massive data warehouse in BigQuery.
Okay, so if AI is growing up, then I guess the first step is learning to communicate properly. The big headline here is Gemini Live on Vertex AI. Now look, we've been promised natural AI conversations for years, right? And it often just means the voice sounds a bit less robotic. What in this update actually moves the needle? What makes it feel different?
I think it's the barge-in feature, hands down.
Barge-in.
You can actually interrupt it. Just think about any automated phone system you've ever called.
Oh God, yes.
You know exactly what you want, but you have to sit there and wait for it to finish its long, pre-scripted sentence. It's so infuriating. Barge-in gets rid of that completely. You can just jump in, change your mind, correct the AI mid-sentence, just like you would with a person.
Ah, okay, that I get. That is a genuine human interaction pattern. So it's not just about raw speed, it's about being less rigid. But how do they do that? Because there's always that awkward pause, na? That speech-to-text, thinking, text-to-speech delay.
That pause is the whole key. They fundamentally re-architected the process to eliminate it. The newsletter has a couple of diagrams that make this crystal clear, actually. The old way is what they call a traditional cascaded pipeline. It's exactly what you described. A clumsy one-way street. Your voice goes to speech-to-text, that's a delay. That text goes to the LLM, another delay. The LLM's response goes to text-to-speech, and a final delay. It's like a slow, leaky bucket brigade.
And every single drop adds to the awkwardness.
Precisely. The new model is called bidirectional multimodal streaming. Now, forget the jargon for a moment. What it really means is it's all one integrated process now. It's listening to you, thinking, and preparing its response all at the same time, continuously. This is what allows it to react instantly when you barge in. It's not just a speed boost, it's a completely different way for the AI to perceive and process a live conversation.
Okay, so the AI can talk to me like a person, which is amazing. But that's only half the battle, isn't it? What's the point if it can't actually do anything for me in the real world? I guess that's the bridge to our next topic. How do you get this conversational AI to connect with all your existing tools and databases?
You've hit on the next stage of its growing up journey, basically. The answer in this newsletter is a new standard called the Model Context Protocol, or MCP. The analogy that jumped out at me is, think of it like USB-C for AI.
Oh, I like that. That makes sense.
For years, right, every tool had its own weird proprietary plug. You needed custom code, a special connector for every single API or database. It was a complete nightmare. MCP is Google's attempt to create one standard port so your AI can connect to anything without you having to build a dozen custom adapters. It's a massive quality of life update for developers.
So which tools are getting this USB-C port first? What's the rollout plan?
So the initial rollout mentioned is for 4 big ones: Google Maps, Google Compute Engine for your VMs, Google Kubernetes Engine for containers, and of course BigQuery for your data. And crucially, API, which is Google's API management platform, also supports MCP. This means you can take all your existing company APIs and make them AI ready with proper security and governance.
Really?
Yes, they even show a screenshot where MCP is just another API style you can select, right next to REST. That little detail, it speaks volumes.
Okay, so connecting one AI to one tool is a huge step, but the newsletter points to something that sounds even more complex: almost like sci-fi, getting multiple AIs to work together as a team. It gives this example of a business forecast agent. How does that even work without them stepping on each other's toes?
See, this is the part that I think is a real glimpse into the future. For years, the obsession was building a single, all-powerful AI, a digital brain. This suggests that might have been the wrong goal entirely. The real power comes from creating entire digital teams of specialists.
Right. You don't hire one person to be your CEO, your accountant, and your lead engineer.
You build a team, exactly. AI is finally catching up to that basic organizational logic. The architecture they show is brilliant. A user asks a complex question like, project our Q4 revenue based on current sales data.
Okay.
The central business forecasting agent acts like a project manager. It doesn't know how to do everything itself. It sends a request to a data agent, a specialist whose only job is to query BigQuery for sales figures. That data then gets passed to a prediction agent, another specialist that runs the forecasting models. Each agent does one thing and does it well.
So the user just sees one answer, but behind the curtain, there was a whole coordinated effort happening.
Correct. It's a design pattern called a multi-agent system. By breaking a problem down, you get more accurate, more reliable, and frankly more auditable results. You can check the work of each individual agent. This is a move away from the single monolithic black box AI.
Okay, so we have this incredible power, but you can't run a supercar on regular petrol, na? This brings us to the hardware, especially GPU memory. The newsletter has this fantastic no-nonsense guide on high bandwidth memory, or HBM. It basically answers the question every developer has: how much do I really need without going broke?
It's the number one bottleneck. And the guidance here is very, very practical. They break it down into tiers. If you're using a GPU with, say, 16 GB of HBM, it's fine for basic tasks, maybe some fine-tuning with very small batch sizes. But the key takeaway is expect it to be slow. Don't plan your production workload around it.
That sounds like the entry level, just learning option. What's the sweet spot then?
The newsletter calls 24 GB of HBM the recommended starting point. It gives you a good balance of speed and cost, especially for those common 4 to 7 billion parameter models a lot of people are using. But if you're a power user, you need maximum speed, or you're working with these massive 20 billion plus parameter models, then you have to step up to 40 GB of HBM or more. Anything less will just be a frustrating bottleneck.
Which makes sense, but this brings up a bigger question. You spend all this money on GPUs, you set up these complex agent teams. How do you know if it's actually working? Is it making your business better, or is it just a cool science project?
A very expensive science project if you're not careful. This is where the newsletter points to the DORA framework. That's DevOps Research and Assessment. It argues you need to go beyond just asking developers if they feel more productive with AI coding tools. You need to measure concrete outcomes. Is your code quality improving? Are you shipping products faster? Is the performance better?
And I'm guessing the AI can't just fix everything on its own.
Not at all. The key insight here is that AI is an amplifier. It makes good development practices great, but it won't fix a broken process. The framework highlights things you need to have in place already, like strong version control, working in small batches, having a clean data ecosystem. If your foundations are shaky, AI will just help you build a shaky house faster.
That's a great point. And the more capable these agents become, the scarier they get from a security perspective. It's one thing for an AI to write a poem. It's another for it to have access to your production Kubernetes cluster.
Absolutely. The Cloud CISO Perspectives report for 2026 is mentioned, and it points to two big shifts. First is agentic security. This idea of using AI agents to defend your systems, automating threat analysis and incident response. But the flip side is the need for AI fluency as a defense. Your security team now needs to be AI experts just to understand and counter the new kinds of threats that are emerging.
The newsletter gives a really fascinating cutting-edge example of this, securing an AI agent that manages a crypto wallet. I mean, that sounds like a disaster waiting to happen.
It does, but the security pattern they describe is very clever. It's built on a propose and approve model. The AI agent can craft a transaction. It can figure out it needs to send 10 coins from wallet A to wallet B, but critically, it does not have the private key to sign and execute that transaction.
Acha, so it has the intelligence but not the authority. Exactly. The unsigned transaction is sent to a completely separate, locked-down system called a Trusted Execution Environment, or TEE, for the final signature. The agent proposes, a secure system approves. This simple separation of duties prevents a hacked or rogue agent from draining the wallet. It's a classic zero-trust principle applied to AI. You don't blindly trust the agent, even though you built it yourself. And that principle applies more broadly, right? Not just for crypto?
It has to. The source provides a simple foundational checklist for any AI project. You have to secure it on 3 levels: the infrastructure it runs on, your GKE cluster, your Cloud Run service, the data it accesses, and the model itself. It has to be a multi-layer defense. One layer is not enough.
And speaking of defense, let's just pause for a second. The newsletter flags an urgent security alert that you need to act on right away. It's a vulnerability called React to Shell CVE 2025-55182.
Yes, this one is critical. It's a remote code execution flaw in React and Next.js, which are incredibly common. This isn't some minor bug. It's the kind of thing that leads to major breaches.
So what's the immediate action plan? The source is crystal clear here. Patch your versions immediately. Don't finish this deep dive, don't go get coffee. If you use React or Next.js, go check your versions. And just as importantly, Google has already released specific Cloud Armor WAF rules to block these attacks. Apply them. It's a 2-step process, right? Patch and protect.
Absolutely.
Alright, that's a serious one. Now, if all of this, new interaction models, multi-agent systems, security protocols, if it feels like a lot to absorb, the newsletter does have some good news.
It does. It highlights that Google is offering a whole slate of free AI training courses, suggesting it could be a good way to use any downtime over the holidays to get up to speed. There are a few that seem particularly relevant to what we've been talking about today.
Which one stood out to you?
So there's kickstarting application development with Gemini Code Assist, which is a great starting point. And for the more advanced topic we discussed, there's a course called Use Model Context Protocol, MCP, Tools with ADK Agents. So you can go from theory to practice with this stuff.
And once you're trained up, there's a new tool for actually designing these systems. It's called the Application Design Center, and it's now generally available. What is this thing? A replacement for drawing diagrams on a whiteboard?
It's sort of a whiteboard on steroids, you could say. It's a central hub for designing your cloud architecture, but it's integrated with Gemini Cloud Assist. So you can literally describe the application you want to build in plain English, and it will start generating the architectural diagrams and configurations for you.
And what if you already have a complex application? Can it help with that?
Yes, and this is a key feature. You can import your existing Terraform configurations directly into it, so you can get an interactive visual representation of the infrastructure you're already running, which can be incredibly useful for understanding, modifying, and managing it.
That's a cool feature. But I can also see how a tool that auto-generates architecture could be dangerous if you don't really know what you're doing.
That's a very fair point, and it's worth adding a note of caution. While it's a fantastic visualization and acceleration tool, it's not a magic wand that will fix flawed infrastructure as code. It's a better map for the experts who already know the territory, not necessarily a self-driving car for beginners. You still need deep cloud and Terraform knowledge.
So, for the folks who want to become those experts, are there any other resources in the newsletter worth flagging?
There are 2 guides that are absolutely essential reading. The first is Master Generative AI Evaluation. This is so critical. It is not enough to build a cool AI demo. You need a rigorous process to prove that it's accurate, safe, and reliable before you let it anywhere near your customers. This guide covers everything from evaluating a single prompt to testing these complex multi-turn agent systems we talked about.
And the second one?
The future isn't one giant AI, it's a collaborative ecosystem. This guide explores the design patterns for making that a reality. It's required reading if you're building these next-generation systems.
So let's just zoom out. What does this all mean? The big picture from these updates is that AI on Google Cloud is past the awkward teenage phase now. It's becoming more conversational with Gemini Live, getting its first set of keys to the real world with MCP, and learning to work as a team with multi-agent systems. The tools are here and they are seriously powerful.
And as the tools mature, the whole conversation is shifting. We are moving beyond the initial wide-eyed question of, can we even build this, to the much harder, more important questions. How do we build this efficiently? How do we measure its real-world impact? And how do we secure it properly at enterprise scale? This isn't the hype cycle anymore. This is the implementation and integration phase of the AI revolution.
That's a perfect way to put it. We've spent this time talking about how to connect AI agents to tools and to each other, creating teams that can execute incredibly complex tasks. As these systems become more capable and more autonomous, the next great challenge won't just be about engineering their skills, but about embedding their values. So the question to think about is, what does it mean to build not just a smart agent, but a wise one?